Geometry lesson on properties and conditions for kites and trapezoid. So we'll begin with the definition of a kite. So kite is a quadrilateral with two distinct pairs of congruent consecutive sides. So we know that these two are congruent and these two are congruent, but these two are not congruent to each other, right? So that's what they mean by that. So interesting observation that we should have before we start going into this one is that essentially this is made up of two different isosceles triangle with a common base, right? Right, that's one way to think about that. And every time that we have, let's say, oh, I don't know, something like this and these like this, what do you know about this point, right? Right. So just keep that in mind. Okay, let's walk through each one. It says that if it's a kite, then diagonals are perpendicular, right? But we know that uh, the point R, right, and point P, so points P and R are what? On, are on, that was pretty bad, sorry, on perpendicular bisector, right, of QS, right, by perpendicular bisector theorem. So that tells you, because of that, that if they're a perpendicular bisector, the keyword is perpendicular, right? So then, therefore, the PR is perpendicular, okay, to QS. Not only that, it bisects them, okay? And then the second one says the quadrilateral is a kite, then exactly one pair of the opposite sides are congruent. Well, one of the things you could do is that you could show that this triangle and this triangle are congruent by saying that PR is a equal to PR by reflexive property. So it means that PQR is congruent to PSR, right? That tells you that this angle and this angle is the same, and this angle and this angle is the same, right? Right, exactly. Okay, so now, but there's no reason to believe that these two are the same. In fact, it shouldn't be, right? Because the length is different. So you can make that argument. However, we could show that these two angles are the same because if these two triangles are congruent, so you got to do that one, right? So QS is reflexive property, and so we know that this, sorry, hold on a second. Yeah, so if that's the case, we know that if these two are the same, and then we know that this angle and this angle is the same, right? If these two sides are the same, this angle and this angle is the same. So when you add these two, they have to be the same. Yep, that's how you would do that one. And anyways, so you should think through each one, the last two. I'll leave that up to you for now, right? And to see if that makes sense. See if you could do them. Okay. All right, guys. Hmm. So knowing that, could you do these? Right. Let's use those properties, guys. Okay. If there's not enough space, what I'll do is just do that. So it's asking us to find CBE. So CBE is this one right here. Okay. We know that the BAE is 32 degrees. That's 32. And I know that this also has to be 32. It's BCE right there has to be 62. And I know that this has to be the same, 62, right? All right, because I know that this particular one, triangle, and this triangle are congruent. So by CPCTC, that has to be the same. Okay. Now it's asking for CBE, CBE. So this angle. Well, we know that this is a right angle right here. Another thing that we know is that this is a right angle. Therefore, we know that the measure of angle CBE plus the measure of the angle BCE is 90 degrees. If I ask for a reason, the reason would be why. Because two acute angles of the right triangle are complementary, right? Because we know that. And now we see that BCE is 62 degrees. Doing a little bit of algebra, we know that that has to be 28 degrees. Okay. All right, guys. You know what? I know that writing too much in the red could be a bit overwhelming. So let me change that to dark gray. It's not quite black. All right, guys. Let's look at ABE, shall we? So what exactly is ABE? ABE. We're looking for this angle right there. Is that right? Okay. I think for the same reason, right? So we could say the measure of ABE plus the measure of the angle BAE is 90 because same exact reason, right, guys? Because two acute angles of the right triangle are complementary. So knowing that, we could substitute in for the given information, which is BAE has to be 32 degrees. And angle ABE. And doing a little bit of algebra, angle ABE has to be equal to 58 degrees. All right, guys. So there are my answers. Okay. All right. So what's up next? Going to the next page. Oops. Sorry. This is the part that I didn't write on. All right, guys. So we're going to be proving that the base angle of the isosceles triangles are congruent. Okay, before we do that, what exactly is a trapezoid? Trapezoid is a quadrilateral with at least one pair of parallel sides. So generally speaking, we accept that there's one parallel sides, right? And that two non-parallel sides are called legs, and two parallel sides are called base. And for isosceles trapezoid is when the two legs are congruent. The way to think about this, for me personally, right? If you have an isosceles triangle and you cut off the top, so this part right here, guys, to me represents the isosceles trapezoid is actually a portion of a isosceles triangle. And you could think of it this way as well. If you extend it out this way, that creates a triangle, doesn't it? Right? So I like to think it that way. Okay. So it makes it a little bit easier to think through this. Right. The other two sides are legs, and they could be parallel or they're non-parallel sides. That was the key information, guys. These two sides cannot be parallel. So let me actually alter the definition because I don't know why it's written this way. Is exactly one pair of parallel side because it has two pairs of parallel sides. We call that parallelogram, right? Sorry about that, guys. All right, so trapezoid is a two pair of, it has two pair of base angles, right? And each pair consists of two adjacent angles to one of the base. An isosceles trapezoid is the one with legs are congruent but not parallel, okay? So these will be one set of base angles, and that will be, oops, my bad. What I meant to say was that these two angles will be the base will be the same, and these two base angles will be the same. And in this particular case over here, there's no information to say what these are. But we do know that because they're parallel, do you see that, guys? XY, and let's call that PQ. We know that the X plus Y is 180 by same side interior angle theorem, right? And P plus Q are supplementary or equal to 180. And these two is true by same side interior angle theorem. Why? Because these two sides are parallel. Two bases are parallel. Okay. All right, guys. I hope you were able to write all that in. Okay. Now, there are three isosceles trapezoid theorems. which is to say that quadrilateral is an isosceles trapezoid, then each pair of the uh, base angles are congruent, right? So given this information, guys, they're the same and they're parallel. The first one is that the base angles are congruent. See that, guys? Right. Here we go. And then the other is that the trapezoid has one pair of congruent angles, then it is a trapezoid isosceles. Okay. So if you have at least one of them, then it is considered trapezoid isosceles. If you have one of these guys, you could clearly show that these two are the same. Because if they are parallel, right, these two has to be supplementary, right? So let's say, for example, that was 100. Then this has to be 80 degrees because they have to be supplementary. So the fact that this are both 100, then it naturally results that the other two has to be, other two base angles, then has to be congruent, right? The other is that if you have isosceles trapezoid, the, if and only if the diagonals are congruent, right? So, and you could clearly show that by indicating that, uh, creating this right here, guys, right? And separating out the two triangles. I'll leave that up to you for you to work on it, guys, okay? All right, why don't we work on the this right here, guys? Do the complete proof of the first isosceles theorem. A and D are congruent. How? Hmm. And there's some helpful hints in this graph is that um, apparently we're supposed to draw a segment, right, E on AD such that they're parallel. All right, guys? And you're allowed to do that because of parallel postulate. Okay, guys, do me a huge favor. Why don't you go ahead and stop the video and work on the problem. All right, guys, we're back. And this is how I did it. Okay. The first thing I did is I wrote out this one that's given to us. And as I indicated, I drew EC such that EC is parallel to AD. Oops, I forgot to write one important thing. And draw. Okay, sorry about that. I'm going to have to move this around a bit. Sorry about it, guys. There you go. All right. And the addendum is, okay, where E is on segment AD, right, such that EC is parallel to AB. Okay. Yeah, you still have to indicate that the E has to be on AD. You could do that because of the parallel postulate, because through a point C, not on this, there exists exactly one parallel line to it. Okay. Now, once I do that, we know that these two are parallel. But we also know that these two are parallel, do we not? Because of that, A, B, C, D, A, B, C, E has to be parallelogram by definition of parallelogram, because when both opposite pairs are parallel, then it's parallelogram. And because of that, we know that A, B, and C, E are congruent because the opposite sides of the parallelogram are congruent. And we also know that CE and CD are congruent, right? Why? Because it was given to us that the AB and CD are congruent. That was given information. And if because of that, this is congruent to this, and this is congruent to this, by transitive property, these two are congruent. Transitive property of congruence. The second thing, now, once we know that, we know these two has to be the same. Why? Because if you have isosceles triangle, its base angles are congruent. Isosceles triangle theorem. Okay, so if you want to write that as a isosceles triangle theorem, it's up to you. Okay, and then now we know that the angle A, is congruent to angle CED, right? We can't say angle E, you know that, right? because it's ambiguous what it is. So you have to use 3 points, right? That is congruent. This angle, this is was congruent because of the corresponding angle theorem, because these two are parallel. And then we know that the A and D has to be congruent. The reason is same as 5, which is transitive property of congruence. Congruent angles, right? Let's look at Y. We know that the angle A is a angle to CED, and CED is equal to D. So by transitive property, A is equal to D, right there. And that was it, guys. Okay. All right. So what to do next? So we got some problems that we need to work on, right? Right here. So using theorems about isosceles triangles. So we have um, this question. So we have a railroad bridge that has side sections that show isosceles trapezoid. So these two are parallel. These legs are the same, right? A, B, C, D represents one of these sections. And then AC is 13.2 and BE is 8.4, right? And how do I do that, right? Let's try and find DE and find the value of X so that the trapezoid EFGH is isosceles. So these two, okay, why don't I leave it for you guys, all right? Why don't you go ahead and pause the video and see what happens, all right? So, all right. All right, guys, here we go. Well, we know that AC is congruent to BD, right? That's one of the theorems. And we know that the BE plus ED is equal to BD, right? So substituting for the values, we know that the ED has to be 4.8. All right. And for the find the value of X, so for this one, well, we know that the base angles of the trapezoid, in this case, that's isosceles, has to be equal to each other, right? So we know that the base angles are the same. So setting it equal to each other, guys, we know that the X has to be plus or minus 5. Plugging the negative 5 into it, we get a positive value, right? So that negative 5 is okay. Sounds good? All right, guys. All right, so we have the second part of this, which is a trapezoid bisegment theorem. This is very, very similar to, actually, never mind, okay? Anyways, the midpoint of the trapezoid of segment whose endpoints are the midpoints of the leg. What that basically means is the following, is that when you have a trapezoid, right? And then X and Y represents the midpoints of the two legs, right? This right here. So basically that is the mid segment. Now, if you sort of think about it, I kind of started saying it, but kind of stopped. This is very, very similar to the mid segment theorem for the triangle, right? In that case, if you had a midpoint like this, we learned that at this point right there was equal to, let's say, A, B, C is 1/2 of AC. And if I call this XY, and it also told you that the XY is parallel to the AC. It's very, very similar, guys. Okay. So if you pretend that the BC was a point and that was a 0, you actually will end up with the same thing. Anyways, coming back to this. So if you have a mid segment over here, guys, right, what this theorem is basically saying is that the XY will be parallel to the base, and that because it's parallel to this, all three of them will be parallel. That's the first thing. And the second thing is that this is the average length of this two. Okay. All right, guys, I'm going to set aside the proof for this. And why don't you guys go ahead and try to solve this right here, this one and this one. Okay, guys, I'm going to assume that you finished it, and that is the work right here. Okay, so we know that xy is the average value of this two, right? So doing the quick calculation, it turns out that it's 11.4. And we know that this is average of these two, and I write down the equation for that. And instead of plugging in, I could multiply 2 to both sides. So 2PQ is equal to KL plus JM. And we know that PQ right here is 9.8. Okay, so that's double that is equal to sum of these two. And we know that KL is 8.3. Plugging it in, solving for JM, turns out to be 11.3. All right, guys? Okay, so here is your turn. Why don't you pause the video and see if you could do the problem on your own. Okay, guys, so I'm going to assume that you're done with this. So the answer for that is right here, is 12.6. Okay, guys, I'll see you in the next video, right? Have a good night.